This is a code walkthrough for the example file LoopingForEndless.java. This file demonstrates that a for loop can result in an endless loop just as well as a while loop can, although it's probably not quite as common. So in this file we've got several examples of for loops, and notice how this is structured. We have each one of these for loops enabled by a surrounding if statement, and these if statements are controlled by these Boolean flags. So to enable any one of these endless loops, and obviously we only want one of them to be endless at a time, we need to switch these flags and recompile. Notice the syntax here. We don't have expression loop to equal true or false. Because this is a Boolean variable itself, we can simply have the Boolean variable itself as the condition. Okay, so as always, I'm going to start this by compiling this file. And let's give ourselves a little more real estate here to see the output. And I'm going to look at these loops one at a time. Rather than using the debugger, I think we can simply look at these by demonstration. This first loop here, this first loop is what a properly constructed for loop should look like. We've got a initialization, a loop condition, and a loop update. And so if we run this, we'll see that it goes through the expected 5 times. This is what we want a well-behaved for loop to act like. By contrast, let's take a look at this second example, and we will turn this second flag true, save this, compile it, and before we run it, let's predict what's going to happen. This is going to be an endless for loop because this condition is always going to be true. We've got this backwards. If we're starting at 1 and we're incrementing, this condition I greater than or equal to 0 is always going to be true. It's never going to be not satisfied. So this is going to spew endlessly with an increasing value for I. Let's try it out. And there's our endless for loop. It's going nuts. So again, the only way to stop this is to manually end it in JGrasp. And we'll clear this. And let's go on and consider this third case. Actually, we'll go back and correct that one. So in this third example, we fixed the loop condition, but now we're incrementing in the wrong way. We're going down. So we're starting at I equal 1. We're trying to keep I less than or equal to 5, but our loop index is decrementing away down from I equals 1. So this will be successively larger negative numbers. So let's save this, recompile it, run it, and sure enough, we can see that this is looping endlessly with an increasingly negative value of I. So again, let's end this, clear this, and let's consider the fourth example. Save that. Now the problem in this fourth example is that we've neglected to specify some sort of update to the loop. So the loop starts at I equal 1, checks that I is less than or equal to 5, but the value of I never changes. It never changes away from 1. So this is going to loop endlessly with a loop index equal to 1. This is a problem sometimes because technically the elements of a for loop statement, strictly speaking, are optional. So if we neglect to provide an update, this code will compile just fine, but it'll loop endlessly. As we'll show here, we'll compile it, run it, and as we can see, we've got no update, so the index never changes from its value of 1. The condition is never satisfied. We've got an endless for loop for a different reason. So again, we'll end this, clear this, and let's go back and re-enable. I'll disable that fourth example and enable this last example. Save that, and we'll scroll back down here. Now this is an endless loop that is analogous to the while true endless loop we saw earlier when considering endless while loops. This is the type of structure we might see perhaps in an embedded systems application. This is more of an intentional endless loop, but this is also one that can come about if we again forget to include the three elements of a properly formed while loop. So this one is just going to spin endlessly with no possible changes to the loop increment. So if we compile this and run it, we see the same thing. So again, we need to stop this and clear it. And again, the common thread in all of these is that something is amiss with the way we've declared the for loop. But fortunately, we can see right away that something's wrong because we've got output spewing. If, for example, we didn't have any outward manifestation of what was going on inside our loop, I'll save this, compile this, and run it again. This is an endless loop. This one is spinning endlessly, but we can't see that. And from our perspective, it looks like our program is hung. So if you suspect that you've got some kind of endless loop going on, one way to diagnose it is to put some print statements in there to get some visibility into what's happening inside the loop. Of course, a better way is to use the debugger, but if you don't want to use that, some print statements are the way to go to diagnose what the problem is. Okay, that's it for this one. Couple different manifestations of an endless for loop, which can crop up if we're not careful in setting up our loops.